Really?
Hi, everybody. Let's huddle at this side. We're about to start. Thanks for coming. This is our February installment of the San Francisco Computational Design Institute meeting. We have a great speaker today and a great topic. This session is being recorded and transmitted live, so we have our largest sign up ever in SFCDI history. We have about 600 people online. So in deference of the people online, please try to stay quiet because these microphones are very sensitive, and so they might pick feedback on the line. So please let's be mindful about that. For those who are joining us online, you all have been placed unmuted to avoid undesirable noise. But we're going to be monitoring the feedback for questions. Unfortunately, we don't have a lot of time to respond to questions on the fly. We will pick some of them at the end, and we can continue the conversation on our website or contacting our speaker directly. Few just announcements for those who are here on our space. This is Gensler San Francisco. The restrooms are right on the side. You need to use it. Not side. And please follow us on our social media. Some of them are here on the screen. Our blog, you can subscribe to get updates live. Our email, if you're interested in speaking or collaborate with us, follow us on Twitter, LinkedIn, and Facebook as well. My name is Cesar Escalante. I'm the founder and president of this organization. Just a quick disclaimer: there's a lot of Gensler staff in this room. The topic of today is Rhino Inside, and this is an industry talk open to anyone. But if you are from Gensler, I just want to make sure that if you have questions about how we're going to use this technology in the office, please reach out on the side to one of your design technology managers, because we have in parallel a deployment plan that we want to follow up. Recently, we had a roundtable in San Francisco hosted by Robert Otani, and Alberto organized it and attended. He's going to do a very quick 2-minute overview of how that event went.
Thank you so much. So I really would like to thank Robert Ortani, the CTO of Thornton Tomasetti. Last week, he flew here in San Francisco and he gave a really nice workshop of all the open source projects and software they are developing in-house, and also a really quick tutorial about Rhino and Grasshopper for free. And then we joined all together this inspiring roundtable. And I would like to thank all the companies that participate, like Apple, Google, Disney, HOK, SOM, and many others. It was a really inspiring roundtable. A lot of ideas came out of it, especially from people also online and feedback. The main point was around open source, sharing software, collaborating all together in something bigger that can be a software, basically, all of us can contribute in. So he was pointing at the fact that in all his project, open source project, people only fork, so basically didn't commit back. So we would like to raise this kind of awareness of sharing and improving the software. And this initiative that we are taking are basically on the main mission that we designed during this roundtable. So thank you so much. That's the microphone again to Cesar. Yeah, so we want also to announce this hackathon, basically always aligned with the main mission. It's going to be in London in April. If you want to participate, it's the AC Tech Hackathon organized by TT Corp.
And there have been changes at the start of the year on the composition of the SFCDI committee. We unfortunately need to say goodbye to Danny Bentley and Colin McCrone and Alberto. They're stepping down in their roles in the organization. They we appreciate the contribution to the group and how strong our community is based on their work. But at the same time, we want to welcome 2 new members. Hannah Tono steps in as the new secretary of our group. And Enrico Chiona is a membership, a large director / product development. We have great plans for the year, and I welcome the new 2 members into our group. I hope that their contribution will make this group grow bigger and better. Another quick announcement that we have a workshop scheduled for March. Peter Meter is going to be facilitating a workshop on machine learning and computer vision at Microsoft. Space is limited, so go to our website to register. And well, let's welcome Ehsan Iran Najad. He is McNeel's Rhino.Inside developer. He's graciously fly from Seattle to join us live. Ehsan is also well known as a pyRevit developer. We are honored to have him in-house. With that said, I'm going to hand him control of the presentation. So welcome, Ira.
Thank you so much. Technical. Hey everybody, my name is Ehsan Iran. You might know me. Some of you might know me from the pyRevit project. I've been working on it for a couple of years. I've been super lucky to be able to join McNeel recently to sort of like work on the Rhino.Inside.Revit project, which is an open source project. I am super lucky and super happy to be able to be part of basically another very large open source project for Revit and AEC. I'm going to give you a little bit of information about what Rhino.Inside.Revit is, and then I'll hand off the presentation to Scott Davidson from McNeel that's going to talk about Rhino.Compute, which is sort of a web server, sort of like running Rhino that you can incorporate into your web applications and whatnot. And after that, hopefully we have enough time to open for a few questions at the end. Okay. Okay, so let's talk about what Rhino.Inside.Revit is. First of all, Marcello Scambelluri, he was supposed to present today, but he couldn't make it. He's going to talk about at some point, I think next month or something, they're going to reschedule that talk. He's going to talk about Rhino.Inside, basically Grasshopper and Dynamo running over Revit and the comparisons and the workflows and stuff. He's a book coming up. He's a trainer. So make sure reach out to him. I'll have his contact information at the end of the talk. So a little bit of information about Rhino.Inside.Revit. Generally, there are 3 components into this project, basically: Rhino, Inside, and Revit. And we'll talk about each one of these very quickly to just give you an idea of what's going on. Let's talk about what Rhino is. For us, Rhino is an amazing tool because it has a couple of components that are really valuable. One of them is the Rhino Geometry engine. It can work with meshes, with NURBS, with Rhino 7. It can work with sub-Ds. So you have access to an incredible suite of tools to do basically anything you want to do on these kind of geometries. The second component is the API. The Rhino Common is a famous API that Rhino has. You have access through it through Python programming languages for Rhino Python and Grasshopper Python. And basically you can automate any sort of geometry creation that you want to do over Rhino. The third, and arguably one of the most component part of this whole ecosystem, is a portable file format. Everything that you sort of like automate and create using this geometry engine and using the API will be stored in a document format that's fully portable, and it's open source. So there are APIs around accessing the information inside the 3DM. You can read and write files. You can access all the information inside it, whether it's geometry or metadata, and basically sort of like own your data. On top of this, we have Grasshopper sitting that uses these components to provide a visual programming language environment to everybody that uses Rhino. Grasshopper comes with an amazing ecosystem of add-ons and sort of like components that have been developed for it for years. It has ties to almost any other industry that you can think of. So it's an amazing tool chain to have. You know, everybody looks cool when using Grasshopper. The second part of this project is Revit. So on Revit, we have sort of like a similar composition of components. One of them, I tend to call it the BIM engine, which it's a geometry and information engine, but it understands the type of geometry and information that we deal with in AEC. It can understand what room is and how to calculate room boundaries and all that kind of stuff. Around it, you have an API for modeling and documentation. Both are really important. We want to be able to automate the modeling process, and we also want to be able to automate the documentation process. So these two APIs are really important. As far as the file format goes, unfortunately, Revit's file format is not very portable. It's good if you stay inside Autodesk ecosystem, but anything outside of that, it's hard to convert it into other file formats. Generally, there's some loss of data and whatnot, so it's kind of like challenging to work with this file type. So again, the BIM engine is super complex. The model documentation API is kind of challenging to work with. It's not easy to get your head around the Revit API and be able to figure out how to do things in it. Revit has been a project that's been going on for many years. There have been many different type of people with different mentalities and different mindsets and different design styles working on this API. So you can kind of like see how different thinking has been applied to the different portions of the API. So you kind of have to get used to working on that. And the file format is, it is what it is. On top of this, very similar to how Grasshopper works, we have DynamoBIM, which is the visual programming environment for Revit. It has an ecosystem. It's not very big, partially because of the limitations of these components that are that's sitting on top of. So we sort of like the Rhino Inside project was a project to address some of these challenges that we have on Revit automation and visual programming languages on Revit. The third part is the inside part, connecting the Rhino and Revit to each other. Assume that this is the Windows logo, that's the operating system. Generally, when an operating system runs a piece of application on your hardware, it runs it in its own, what we call it, a memory space. Applications that are running separately, like if you launch an instance of Rhino, an instance of Revit, they cannot have access to each other through the operating system. This is a security feature because applications are not supposed to be able to access each other's memory and steal each other's information. Any communication between these two applications should be done through the APIs provided by the operating system. But the problem is that there are limitations to that kind of communication that you do, and there's an overhead of like how you can access and move memory from different memory spaces into each other and whatnot. One of the things so this is a no-no. You can't really access sort of like APIs of another application that's running in another memory space. One of the amazing things, or arguably the most amazing thing that Rhino Inside the technology was capable of doing, is that the Rhino developers sat down a couple of years back and sort of like took apart Rhino into its core components and designed it in a way that it could be run headless and it could be run inside other applications. So basically, Rhino Inside Revit is Rhino running as an add-on for Revit. That means that these two applications are running in the same memory space. Rhino can access Revit API directly. Grasshopper can access Revit API directly. Grasshopper components can access Revit API directly. And all the other Rhino add-ons potentially can access any Revit API directly, or potentially any other add-on on Revit that provides some sort of an API. Like if there's a rendering add-on with an API, any of these applications running in the same memory space can access each other's API. So now we had running in the Rhino ecosystem, we had Grasshopper with these three components that we talked about: the geometry engine, the Python API, and the portable file format. On top of those, running inside Revit will give you the BIM engine, access to Revit API for its analysis, computation, dealing with sort of like AEC related geometry types and all that kind of stuff, and the modeling and documentation API over Revit. This is the ideal picture of this project. It is a work in progress, so we are still working on this. We're adding components and whatnot, and I'll show you some of the project, and I'll show you the wiki that we have created for the project. It's something that we're working on, and it's getting improved every day. So this is where we really want to get to eventually. So with that, I'm going to show you a few things about the Rhino inside Revit. So this is going to be a live presentation. Let's agree that this is going to break at some point. I have Revit running. I didn't want to take the time to launch Revit and all that kind of stuff. So Revit is already running. When you go to and install the Rhino inside Revit, and I'll show you where to download the installer and all that kind of stuff. When you sort of like install Rhino inside Revit, you get an add-on under the add-in tab that gives you access to the Rhino that's running on your system. I just wanted to show you this so you know sort of like how you interact with it inside the Revit environment initially. Let's go and talk about the wiki that we have created for the project, and I'll touch on the details of it later. It's Rhino3D.com, the standard website, the go-to for Rhino. But in front of it, you can add /inside and /Revit, and it'll take you to the beta version of the wiki that we have for Rhino inside Revit. There's a really good video on the homepage. There are actually 5 videos in a playlist that you can watch and see pretty much everything that I'm going to show you to you today in more detail without any breaks and stuff. There's information about the project. There's a download button for Rhino inside Revit add-on, and there's a download button for Rhino WIP. The reason that you're seeing 2 different download buttons is that Rhino inside Revit is the add-on for Revit. It requires Rhino being installed on your machine because that's what it's going to tie to. The beauty of this is that Rhino is not going to ship in its entirety as an add-on for Revit. So you're going to use the same instance of Rhino that you're running on your machine for all the other tasks. But when you ask Rhino inside Revit to run that Rhino inside the Revit environment, it uses the same installation that you have on your machine to run that Rhino inside the Revit environment. This project requires the Rhino 7, which is the work in progress at the moment. So you'll be download the Rhino WIP. You can run any work in progress version of Rhino with the sort of like the stable license that you have. So in case of Rhino work in progress that we have right now, you can run it with the Rhino 6 license that you have already purchased. The Rhino WIP also expires after, I think it's about 45 days or something like that, just to sort of like help everybody be updated on the most recent version of the WIP. So get that Rhino installed first, run it, make sure you have the license and everything works, and then install the download and install Rhino inside Revit. That's a tiny installation. It's basically just 1 or 2 DLLs that gets added to Revit. And then when you launch your Revit, you'll see that button over there. All of this information that I'm giving you about the installation is documented under getting started and the installation process. It takes you through the download buttons. It basically gives you all the information that you need to know about the load process in Revit and whatnot. So when I've downloaded and installed all these products and I've launched my Revit and Rhino button is loaded, I can click on this button, and this sort of like add-on inspects the environment, finds the Rhino, inspects the Revit environment, and will generate this Rhinoceros tab inside the Revit environment on the fly. And it will give you access to Rhino, the Python, which is the Python editor inside Rhino, if you have ever used it, a suite of tools and configurations around Grasshopper, and a couple of example samples at the end. This is, again, work in progress, so we are working on this layout of buttons and sort of like fine-tuning it for ease of use and stuff like that. So you might see some of these buttons move around at some point in time. But here's the beautiful part. You can just open Grasshopper from Revit, and this Grasshopper has access to Revit API. This is just like you're running Dynamo over Revit. Same thing happens. I showed you Grasshopper first because I'm generally the one that's most excited about it, but the big part is really here. This Rhino is running inside the same memory space of Revit. These are not two separate applications. See, it's attached to the Revit window here. The way that we have implemented it right now is that if you click back on the Revit window, it hides those windows because of the challenges that we have with the Revit API. We are working on some of these architectural issues to get them fixed. But basically, these two windows belong to the same application, and they're running inside the same memory space. So what does that mean? Let me show you a very quick example. I can draw a wall in Revit, and I can go inside my Grasshopper, and I can go inside the Grasshopper parameters tab. You'll notice that there's a new Revit tab that gives you access to the input data coming from Revit, Revit panel, I'm sorry, and you also see there's a new Revit tab there. The components that are here, again, work in progress. They're moving around, they're changing names and all that kind of stuff. So just be aware of things like that. I have added a lot of custom components into this that are sort of like being tested by the users right now, and we'll implement these as the core components as we go along with the project. And I'll show you the details about these components later on. But basically know that you're gonna sort of like see a Revit tab, and you're gonna see a Revit panel inside the parameters for your input data. So I can say, give me a geometric element component, select one element geometry, and this is a parameter that I have that holds a reference to that wall inside Revit. But what it does in the background is this. So it grabs the geometry from that component, and you can see the preview of that geometry inside Rhino and inside Revit at the same time. What this component did is that because it has access to both APIs at the same time, it can ask Revit for its geometry of the wall. You can convert it on the fly to a standard BREP that is Rhino geometry engine geometry, and basically everything else is standard Grasshopper from then on. I can go and add an element geometry component here to explicitly extract that geometry, and I get a closed BREP. Any other Grasshopper add-on, and I can't emphasize this enough, any other Grasshopper add-on that you have been used to and you have used over the years uses these standard data types that belong to the Rhino geometry engine. From this point on, you can pass this BREP to any component. To your analysis application, you don't need to maintain two different installations of Ladybug tools anymore. Because you can use the ones that come that you get installed on Grasshopper and pass the BREP and all the analysis geometry and the metadata and stuff that you want directly from the Revit environment to that. The conversion happens on the fly inside the same memory space, and it's super efficient because there's basically no overhead. These two applications are running inside the same memory space. So this is just a super easy example. This getting started article will take you through these examples that I just basically showed you, getting you started and sort of like be comfortable with the environment. And then I'm going to show you a few examples. Some of these might break, so forgive me on the sort of like problems that we have right now. But the software is changing all the time and whatnot. I'm going to open a Revit model here that I have a couple of office floors for. You see a bunch of floors in here, and I'm going to unpin this and delete those. Sure. And then I'm going to go to my Rhinoceros and open a document that I have here that is the office floors model. So this is, imagine like this is a building that I've created in Rhino. And sort of like I think the floors are here. A couple of floors that I have belonging to different buildings. They're generally organized in layers because we don't have that kind of BIM schema inside Rhino. I'm going to move this to the side for now. And I'm going to open my Grasshopper. I'm going to open a definition that I have that says office floors. So what this definition does is that it finds the curves that is inside the Grasshopper, inside the Rhino environment and model. It passes them on, does some geometric analysis on them and whatnot. It passes it to a component that we have in Revit that's add floor by outline. It generates floors of that type. So we have category pickers and we have type pickers. inside Revit. So if you go inside input, you can see model category picker and then type picker and whatnot. You can pick those, and then there are a couple other things that's bringing also into this, like the columns and whatnot. But I'm going to close my Rhino right now and go to the Revit environment. And all of this happened basically by me opening the Rhino model and then opening the Grasshopper definition on top of it. And Grasshopper automatically runs that definition and it generates these floors for you inside the Revit environment. This is the beauty of this, that this floor is a native Revit object. These are not BREPs being built into the Revit environment in direct shapes and stuff like that. This is an actual Revit. There's no difference between this floor and the Revit floor that you generate manually or you generate using Dynamo. So because they're all accessing the same API, they can sort of like interoperate with each other very easily. You can see there are a whole bunch of other columns and a roof that I brought from the other project and whatnot. So if I go into Rhino, I think there should be a roof in here. Let's see if I have the roof. Anyway, so there is also this interactivity that I'll show you later. I don't want to touch on all of these components, not to confuse you at this point. So this would be an example of moving geometry from Rhino inside Revit. You don't have to bring the exact same BREP into the Revit environment anymore. Remember, you have access to both APIs, so you can get the BREP from the Rhino environment, do the analysis on it, maybe on in terms of like in case of a floor, maybe grab its elevation and its outline, and then use those to generate a level and a floor by outline inside the Revit environment. You basically read the geometry and the metadata that you need, and then you create the components that you need inside the Revit environment. That would be one example of how you can bring a geometry from Rhino to Revit. And I'm going to show you one that we have created for Revit to Rhino. So I'm going to use this very complex, amazing model that is provided to us by Autodesk, just for the sake of this project. I'm sure you have seen this this before. I'm going to clean up this Rhino instance. I'm gonna go open a clean model with basically feet configuration unit. And I'm going to open a Grasshopper definition. SFCDI, Revit to Rhino, Revit to Rhino. No, I don't want to. And then this definition has a lot of different components, but basically you can see this module being repeated over the definition. What it does is basically we have a custom Python component that is grabbing these categories from Revit and generates the geometry inside the Rhino environment based on what it's reading from Revit. So this sort of like this piece is collecting the roof categories inside the Revit model, and it grabs the geometry and whatnot. And then on the push of this button, this Python component runs and it grabs that and generates, using the Rhino Common API, generates the BREPs necessary for that inside the Rhino environment. And you can see, like I'm running on a VM, on a virtual machine on top of another operating system. So imagine how fast this runs on your own machines with the sort of like the CPU power and stuff that you have available. I'm gonna do the same thing. The second component is for walls. And this, we kind of like slowed this down intentionally for the, for the effect. So you can see all this stuff like being built. It's not cool to just see all the walls pop up. So this is a lot cooler, like floors. You can grab the floors out of the Revit model. And if I go back to this Rhino model, everything that you see here are basically standard. Let's see, it's still working. Okay, so everything that I see here are standard poly surfaces that you generally model inside Grasshopper. So you can use this model if you want to pass this information to another analysis application, save it as a 3DM and do whatever you want with it. This is a great way of doing it. You can create, this will give you the flexibility to create your custom Grasshopper definitions that extract the geometry and the metadata that you care about based on whatever the target application is. Grab that, put it in Rhino, use the portable sort of like portable file format to dump it in that, and then transfer it wherever else you want to. Another example would be, I'm going to open another one. So let's talk about producing families. I think you'll be excited about this a lot. I'm going to actually create a new empty model here. I'm going to go to my Grasshopper and make sure that definition is closed. I'll close the other one as well. And I'm going to open my Grasshopper and Rhino. Sorry. And then open a model that we have created inside Grasshopper, inside Rhino, that has geometry for a, let's say, a column and a curve, and we want to place instances of this column over this curve inside the Revit environment. So I'm going to close this because the Grasshopper definition that I open has references to this geometry here. I'm going to open Grasshopper. I'm going to say, give me the column and curve. I'm going to go into a Revit 3D view. You already see all this geometry is populated here. I'm going to go to 3D view, and you can see I can grab the geometry from Revit inside Grasshopper. Let's say grabbing the geometry B-reps and the sort of like the curve, and I'll analyze the curve, split it into different points that I want this column to be placed on and stuff like that. But basically this geometry, this B-rep geometry, is coming into a component that says family new, and you give it a name, you give it a template file, you give it the category that you want it to be in, and it would generate a family for you. You grab the first type, and you use another component to place instances of that type at these locations for you. And we do some analysis on the normals perpendicular to that curve at that point to be able to determine the direction of that the column that sort of like to place that in the Revit model. What this means is that this is an instance of a Revit family. So if I open my type editor and select this, you can see that this family is called column right, and that's the first type that's called column right. This means that if I unpin this and say edit family, I'll have access to the geometry. So effectively, Rhino and Grasshopper is generating families for you on the fly and incorporating those into your model. Now, we have this convention right now. This is again a work in progress, so we might change in the future. But basically, you can tell the Grasshopper component whether you want to override the definition of this family every time you sort of like generate it or not. And we could make changes to this. So if you make modifications to the family manually, they will be overridden by Grasshopper or not, depending on what you want and what you choose. You could also grab these families and save them to the outside, save them in external files and stuff like that if you need to. And then another workflow would be maybe let's talk about this, since I still want to give Scott a little bit of time to talk about the Rhino.Compute. I'm going to unpin and delete that. I'm going to go to Rhino tab, open my Rhino. I don't need this anymore. I'm going to clear out that document. I'm going to close this and open another Grasshopper definition that we have created as an example that will give you access to, actually wrong one, this one. See that current wall popped up again? You're using a Grasshopper definition to drive a curtain wall, and we are using a parameter set component to set the number value of the horizontal grid and the vertical grids on this type. So what we are basically doing is that we are creating a wall of type curtain wall 1 by the base curve, which is an arc, and then we're grabbing the connected height. You can increase the height of it if you need to, and then sets the height parameter, and it passes it on to this, sets the sort of like the divisions on the type, and that's basically what it does. So you can sort of like automate and interact with that design the way you want to inside the Grasshopper environment. This is just an example. You can sort of like create all sorts of curtain systems and curtain walls inside the Grasshopper environment. A lot of what you can do is kind of limited to the components that we create for the project. So if there would be right now, the build components that we have are these, so it's fairly limited. And I'll show you how we're working on this project to get it improved and whatnot, and add as many components as we can to this process. So I think I've given you a couple of examples about like moving geometry from Revit to Rhino and vice versa, and automating certain sort of like operations that you do, creating families, creating drawings and documents and all that kind of stuff. I don't want to take too much of the time. I want to, at this point, to show you the wiki in more detail for the project that we have. So I showed you this wiki page. There is this getting started page that make sure this is the first thing that you go to if you're new to the project. Just take a look at it and figure out, get started with the project. There are, every sample that I showed you are under the samples category, and each one of them has sort of a clean template. I'm still working on cleaning these up. So it's fairly easy to work with. There's generally a video associated with the sample. You can download the sample files and their directions on how to use and play with the sample. And then there's a references place that we get to. We'll talk about it. There's a community page. A lot of this is a work in progress. If you have created something, if you have made videos and whatnot about Rhino Inside, let us know. We can place it on the community. And the most important part of this wiki is this guides section. So what we're trying to do is that we are trying to create and offer examples of really good workflows to do certain tasks on when you're running on Revit. So on the side, you can see a lot of different components related to Revit's data model. There are a couple of articles on top of this. This guides, the index page of this guides document, this page will take you through most of these. You'll see a couple of documents on the side, data model elements, parameters, and types, that gets you familiarized with how Revit API and the data model actually works. And then after that, you'll go into different sections. Like I can show you, I can go to views. Each one of these sections sort of like try to cover a certain type of data type inside Revit. Sometimes it doesn't go into too much detail. Like for example, rooms, spaces, and areas are all bundled under spatial elements, because Revit generally treats them the same way. So it's sort of like it tries to stay somewhere in the middle between you as a user and the actual API. By creating these workflows, we're trying to get you familiarized with how the API works. So after a while of like using these components and stuff, it builds a little bit of knowledge of how exactly the Revit API works. So when you actually go inside the API and want to write your own Python programs and C# programs, it's not really too different from what you have been used to inside the Rhino Inside Revit environment. So you can see we're trying to sort of like provide examples for the CRUD operations over each one of these data types. So create, read, update, and delete. They might sound simple in action, but like for example, deleting design options. How does that work? Deleting worksets. You have to make sure that you move the elements that belong to the workset to another workset before you do this. If you delete design options, any view that has that design option associated with it will also be lost. So they sort of like feel easy in sort of like terminology, but when you actually want to deal with them in the Revit API, because of this association that's present between all these Revit elements and geometry and sheets and all that kind of stuff, it makes it a little bit more complex. So we are trying to give you examples of like how we can use these specific components that we have created inside the Rhino Inside project to query views, for example, query views by the system families, and there are notes about the API. It gives you a little bit of detail of how the actual API data types work and whatnot. And it provides download links to this example Python components that we have that will get the job done for that example. And the goal of this is that you get as much feedback as we can from you guys to sort of like be able to fine tune these components before we actually ship it in the version 1. Once we are kind of happy with that the workflow works, then we'll write this down in C# inside the main code base, and there will be the standard part of the Rhino Inside Grasshopper components for Revit. So if you have any questions, a lot of these components, a lot of these pages are in work in progress. For example, for walls, I have laid out the structure of that article, but we haven't really filled the information yet, just because I'm collecting some information from other users that are testing this out and whatnot, and be able to create something that's really good at, at the start. So just be patient with all this stuff. We're working on this every day. And then, so that's as far as the wiki goes. I guess I don't really have anything else to add to this. I'll talk about the forums, but at the end of this section, I want to show you the sort of like the source code for the project. It's open source. If you know C#, you can clone this project, start making changes as you need to. Follow the guidelines that are set for this homepage document. There's plenty of information. If you want to contribute to the wiki, you can. The documents and the guidelines are available on this page, and just feel free to contribute to the project. So that was a demo. At this point, I'm going to hand it off to Scott Davidson at McNeel to present Rhino.Compute. I need to stop the sharing my screen, right?
Be able to get this out. Yes, the control. You have some question in the
Hey, Scott, if you hear us, you'll have to unmute yourself.
I think we need to unmute him.
Yep, good. I'm good now. Can you hear
Perfect.
me?
Okay.
Yeah, perfect. All right. Sorry, we were double muted there. All right. So, can you see my Rhino 3DM slide?
Yep.
Yeah, perfect. So it's not presented, but that's fine. So, just really quickly, I wanted to show another Rhino 7 open source project we're working on. This is about how to access Rhino Geometry within your own projects, how to actually encode Rhino Geometry into your own projects, and how to use Rhino, essentially it's Rhino Inside, but Rhino headless on the cloud. And so we have Rhino 3DM, and we have it now in JavaScript, in Python, in C# and C++. And this is the ability to take to create Rhino geometry, to store it, to encode it, and serialize it and deserialize it. Points, curves, surfaces, B-reps, meshes, sub-Ds now, layers, all of those things can be encoded now using JavaScript, for instance. We can also add data, so you can wrap data around these geometry types, and carry those around as objects. That open source piece, that Rhino 3DM piece, that's free, and you can just download it and use it. And in addition to that, what we've added is a set of libraries called Compute that allow you to set up a server on your framework, your internet framework, your web framework, and through HTTP, make geometry calls to it and get it returned. And so it allows you essentially to get all your Rhino geometry calculations done across the web and return it to a local client. In this case, let's say Chrome. So as an example, this is just a viewer in Chrome using the open source project and using Three.js, right, and then the Rhino 3DM. And you can see what I can do is I can get a lot of the amazing graphics and navigation and Rhino geometry directly in Chrome. There's no Rhino running here. This could be on any Chrome. This is on a prototype. This is coming off a prototype compute server that we run, but in your case, you would download the compute product and install it on your infrastructure if you want to do it. So now one of the interesting parts is not only does it do materials and it does geometry, But another thing that it does is it can actually calculate. Well, here's another thing you can do. I'll just open this up. So this is actually a viewport in Chrome, and I can actually draw. This is drawing in Chrome, but we're creating Rhino curves on the fly, obviously. And so, that's another way to do this. And the last piece, which is the piece that we see a lot of people trying, which is actually running Grasshopper definitions in the cloud. And so I'm going to open this in a new window here. It'll take a minute to calculate. And what it'll do here is I actually have sliders up here with JavaScript. And as I slide these around, drop them, then it will send that information to the compute server. It'll grab it, and then it'll come back with an example. And so in this case, we're just calculating. We're having the compute server calculate a Grasshopper definition on the fly. And again, it's just using JavaScript, nothing super fancy there. So just to take a look, so you can go to Rhino3D.com compute. It explains compute, it explains what the API, there's 2,400 API calls with compute. Explains how to get started with C#, Python, or JavaScript. There's also licensing options now. I think we're looking at core hour billing. So if you were to run your own compute server on your infrastructure, there's a core hour billing charge that you can run, so that as you spin more up, or you want to spin up thousands, you can do that. Anyway, this is the compute project. It actually, you can think of it as Rhino inside a Node.js server, essentially. But anyway, just real quick, if that's something that you're interested in doing. Okay, I think that leaves us enough time for some questions, since we covered so much.
Thank you. So, thank you so much, Scott.
Okay, while you're coming up with the questions and stuff, the only thing that I wanted to sort of like add is the Marcelo Escambelluri was supposed to do this presentation first, but he couldn't make it. This is his website and podcast. He has an amazing podcast talking about AC subjects, and then that's his Twitter handle and his email. Reach out to him. He does a lot of trainings for the companies. If your company needs training, reach out to him. He's a book coming up that he'll talk about in his talk. And also reach out to us at discourse.mcneel.com. The sort of like those three emails at the bottom is the tentative Rhino Inside Revit team, Scott, Kike, and me. Kike is actually the one that started the project. But the best place to reach out to us is at discourse.mcneel.com, because any response to those questions and threads and whatnot will be shared with everybody else, and they can search it and find answers too.
Thank you so much. I really
Thank you.
looking forward to have Marcelo here.
Hey.
I had a quick question for when we translate the Revit models into NURBS within Rhino. Say if the wall has, like, it's made up of a bunch of different parts, right? There's the surface, finished surface, and then the structural. Would that get modeled within the NURBS too?
So this is completely up to you, how you want to transport how much of the geometry to the Revit environment. Revit provides an API that gives you the geometry, the rendered geometry that you see in the view for that wall, right? But it also provides an API to get the structure for that wall as well. So if you want to grab the geometry for all the structure layers, you can do that as well and put it in different layers and whatnot.
But the baseline is just the whole of the wall.
That's the standard one. Like if you grab a geometric element, that's what it does, because that's the standard API, and it works across all Revit elements. So if you throw a furniture in there, it'll still grab the geometry. So it doesn't care about like what kind of schema it's dealing with. But if you grab a specific wall and say I want all the layers, then they can add more components, grab its sort of like layers, and then grab the geometry for those.
Say if you're grabbing a curtain wall, will it
you can split the panels and the mullions and all that kind of stuff separately. Yeah. So if you need to grab the panel areas, if you have openings in the curtain wall and whatnot. Go ahead, sorry. No, go ahead.
Oh. Thank you.
Yeah, this person, you had a question?
Yeah. What's your guys' relationship with Autodesk? Because I'm a little, what's your relationship with Autodesk? Because I've been playing around with Rhino Inside and loving it, but it's a, sort of widely viewed as a pretty big threat to Dynamo. And I'm worried that Autodesk is going to throw some monkey wrench into this whole system.
So McNeel is a separate company. They have been around for past 30 something years. This is an open source project supported generally by the community. McNeel provides the technology behind it. I don't sort of like on a product level, I don't see it as a direct competitor to Dynamo, because Dynamo has sort of like it has a different access level into the Revit API. It's supported by Autodesk. It can do different things than Grasshopper. They're sort of like they're similar to each other, but they could be. I guess the target audience for these two are kind of different from each other. What I'm personally seeing it as a Rhino.Inside.Revit will provide a solution for all the areas that Dynamo can't do anything at the point. And you'll still have access to a lot of the add-ons that are like the Ladybug tools. You have access for both of them, so both workflows are still there.
So there isn't really a fear that McNeil's good or that Autodesk is going to sort of screw with you guys.
I don't know. I guess Scott can answer this. Scott has been with the company a lot more, so he knows the history better. Scott, if you want to chime in.
This is so hard because I mean, in the end, we have a technology that we think might be helpful to you. And so we're going to put it out there, and we're going to put it out there as best we can. And unfortunately, we just can't worry about what somebody else might or might not do when this technology is there, right? I mean, so since it's there, we're going to throw it out there and get it out there as much as we can, and we'll see where it goes. So far, Autodesk has been, supportive, and they know what's going on, and so we'll go from there.
And then the project is open source. So if you have developers in-house and you want to like clone the project and sort of like, just to, safeguard, keep the source code in there and whatnot, there's nothing really stopping you from doing it. Go ahead.
Yeah, I also want to add with this regard that Autodesk can take advantage of this technology, because suddenly their Revit got access to all the wonderful plugins for Grasshopper that were not available otherwise. So I think it's also convenient for them, and that's the reason why they will keep supporting it. But besides this, I have a question for Marcelo. Is it possible through Rhino Inside to, like, once we generate the right geometry and we want to bake it inside our Revit project, can we make it stable there?
Yeah, so there are two ways you can bring geometry from the Rhino ecosystem into Revit. Either use Revit API to create the geometry based on the schema that it has. Like if you're creating a floor, you can create the floor by outline and create an actual floor object. Sometimes there are geometry, like for example, if you have an incredibly complex skin for your building, you can do all the analysis, the geometric analysis related to that skin inside the Rhino environment. And when it comes to like documentation and just having them included in the Revit model, in the BIM model, you can bring it as a direct shape. Revit has this category of objects called direct shapes that you can pretty much throw anything in there. Any parametric mesh surface could exist inside that environment. And Grasshopper, the Rhino inside Revit right now, we have a component that you can just throw any BREP at it, and it will place it inside a direct shape of the category you want. You can mark it as furniture or whatever, and place it inside the Revit environment. Revit. Oh, sorry, Scott. Go ahead.
Yeah, that's right. And all that information is saved in the Revit model. So if you disconnect Rhino and Grasshopper and you send the model downstream in the Revit model, all that geometry carries with it. It's not like you have to have Revit around to actually see the geometry.
Yeah. One of the things that I would suggest, like this is something that I personally tend to do, is that Rhino environment is a lot more mature in terms of like doing analysis and creating models for fabrication and all that kind of stuff. So with having Rhino access directly to the Revit API, you can stop thinking about how I can do this stuff in Revit. Because like this curtain wall, this crazy skin that you design for your building, now you have access to full geometry of it inside the Rhino, and you can create it in Rhino. You can do all the analysis and fabrication that you want to do on Rhino. You can send it to all the sub-consultant stuff and just bring it to Revit for your documentation and rendering and all that kind of stuff.
So I have two questions. So the first question is, if you're modeling in Rhino and you bring it into Revit, what would it be a family and does it categorize it?
That's completely up to you. You can decide how to bring it into Revit model, whether creating it as a family or not. And when you're bringing it into the model, use the default Revit API to create an actual floor that's categorized automatically because Revit knows what this object type is, or categorize it the way you want to. There's really no limitation. You have full flexibility on how you want to bring this geometry into your model.
And the second question is, do you have to save the Revit file and the Rhino file and the Grasshopper file?
No. So yes, Grasshopper definition, Rhino model, and Revit model, they're three separate different files, right? But if in most cases, Grasshopper definition is used to carry over some geometry from Revit to Rhino or from Rhino to Revit, right? So you could save these three models, but whatever they use to sort of like generate inside Rhino or inside Revit will be saved, will be baked and saved inside that model. So you could open your Revit model without having the Rhino, without having Rhino inside at all, and still see that geometry that they're baked into the Revit.
There's another question. If I'm not mistaken, Rhino operates on higher order degree curves than Revit does.
Yeah, its geometry engine is vastly different from what Revit is used.
How are you, like, if we're developing complex geometry that is beyond the capabilities of Revit?
So the API, these components that we're building has an API. Rhino inside itself has an API inside of it. Like, for example, we hit this problem with Hermite surfaces. Revit has Hermite surfaces. There's no definition in Revit Rhino common. We went to the mathematicians in Rhino and implemented Hermite curves and Hermite surfaces inside Rhino common, specifically for the purpose of Rhino. So now Rhino has support for Hermite. It came from the challenge on Rhino inside Revit, but now Rhino Geometry engine has support for those.
So this goes to my question. How are you comparing this to the industrial foundation class, IFC files? And why are you not checking kind of the data set you have to IFC's foundation class?
So the purpose of Rhino inside Revit is to provide a visual programming and automation API environment to Revit. Its direct goal is not to provide a separate set of schema. You could develop components and develop scripts and whatnot to export to IFC, read IFC files and stuff like that. But that's not the sort of like the target objective of this project.
Well, you made portability as a comment.
Yeah.
In your intro. And so instead of kind of creating another file format, I'm just curious why you're not kind of, let's say, continue what you're doing, but why would you not go ahead and check it against the IFC class? See how you could.
To be honest with you,
because the questions that we're having are kind of the same. Like, what is the universal file I can put it in? How can I have, we know 3DM is what you're proposing, but in a way, this other question here is like, what other file can I put it in?
So
that's what I'm saying.
If I want to answer that question, there's no, like in my point of view, there's no universal file format to store all your information in at the moment. It would be ideal if you had something like that, but using each one of these file formats will give you a certain type of functionality. The reason that I didn't mention IFC is because although Revit has some relationship with IFC, the conversions and the sort of like the API around it is not very well built. IFC itself is super complex for a person that doesn't know and want to approach it at first to be able to develop and sort of like write files and all that kind of stuff. The Rhino 3DM file format is incredibly valuable for carrying geometry and metadata. Revit file format is incredibly valuable for putting geometry in there and the documentation and the sheets and all the other information that are around it. So each one of them, to my point, each one of them has a sort of like a purpose. You kind of have to figure out the workflow that you have created and sort of like figure out which one of these file formats are perfect for those. Does that make sense?
Yeah, I think it's part of this exploration that's the key. It's like none of them are universal, but the question is now you can mix and match. It's where is that going to lead us in terms of something that might be more, quote, universal.
Right, and I guess what it might be is a two-part system, kind of like an OBJ file or an FBX, in the sense that you have your geometry and then your
Yeah, and if you use the Rhino Inside Revit sort of like project to create the geometry that you want in the correct categories, floors and whatnot inside Revit, you can then also export it to an IFC, and it will carry on this schema and whatnot, and it will generate a correct IFC for you as well. So it's as Scott mentioned, it's just that it gives you another set of tools that are super powerful, like 3DM file format. You can throw it in the web and it would show up in a web browser. You can use it for analysis. A lot of different applications make it. You can send it to the fabrication shops. They can read it. So it's a very, very portable file format. I'm not trying to say that you should store your models, Revit models and all that kind of stuff in 3DM. It's just that you have access to 3DM now. No. I'm just trying to be more clear. Yeah.
I always find that kind of some lift can be really powerful. That's why.
Okay, one more last question, and then we'll break the session. We can always hang out afterwards and ask additional questions to our panelists. Sorry for the guys on the line. We just ran out of time to go through your questions. We will try to address them at a later time.
Yeah, I had a question. So when I'm using Grasshopper in Rhino, there's like a bake function wherein, because like the geometry isn't real in Rhino until you bake it. In your demo, it really looked like the geometry was real in Revit and there was no baking. It almost seemed like it was this direct translation.
So there are two different types of components that you have access to in Grasshopper. Let's say you have let's just give an example of a circle, right? A circle component that creates a circle for you. The normal Grasshopper approach is that you throw a circle in there and then you right click on it and bake it into the Rhino environment as an actual circle, right? Before that, everything's a preview. So if you do this inside the Revit environment, you see the same circle preview inside Rhino and inside Revit at the same time, both previews. After this, you have components that are specific to Revit that actually generate geometry for you inside the Revit environment. So let's say there's a circle component inside the Revit tab that creates a circle. You can pass the circle into the circle component that's for Revit, and it would create a circle for you inside the Revit environment. That's what a floor component does. That's what a wall component does. And this is partly because Revit API, Rhino API, you can create a curve and hold it in memory and not have it in the document. In Revit API, it's kind of different. You can't create a wall and just have it in memory. When you create a wall, it adds it to the model. So they kind of work differently from each other. And that's part of the reason that you have this whole different set of components for Revit that will give you the capability to create what you want to. But if you have generated the geometry for that wall or the curves or the lines and stuff like that, you can see those in preview before you actually create the wall. And you can see the geometry, preview of the geometry of the wall after you created the wall. So you can see all sorts of previews of the different geometry. And you can turn on and off the previews on the components and see whatever you want to see.
Thank you.
All right, it's a few minutes past the hour. With that said, I think we're going to conclude the session online. Thanks everybody in the webinar who were able to connect. A big applause to Ehsan again for making it into here.
Thank you.
And he still stick around for a few more minutes.